A very good morning, students. We are going to start with Pharmaceutical Chemistry 2 syllabus of your second year. We are going to start with the very first chapter. The first chapter is Hetro-cyclic systems. The first chapter today we are going to start is with the study of your heterocyclic systems. Prior to that, one should know what is heterocycle. Okay. Now these are two words which are being clubbed together. That is hetero and cycle. Heteros means what? Different. Other than the routine one. Heteros. Okay. Now in the chemistry language, let's start with the nomenclature as well. Prior to that, studying heterocycle, let's study what is the need or what is the justification or what is the origin that we felt the need for going for the classification. Okay. So we will have to know classification and nomenclature. If you know these two things, if you know classification as well as nomenclature, then it's very easy to understand what is the meaning of your heterocycle. Now the thing is that prior to beginning with the first chapter, let's have a glance at what is the profound meaning of chemistry. Right? We know chemistry means what? The study of all organic and inorganic compounds. Now here we are going to study with your all organic pharmaceutical chemistry. Means all the organic structures related to your carbon, hydrogen, oxygen and heteros. Now heteros means what? That is your other than your carbon and your hydrogen. These are your homo. Okay. These are your organic compounds. Now your oxygen, N and S. These are heteroatoms. This will be your homo atoms. And this is your hetero. Okay. Now, if you place in an aliphatic chain, that will be your aliphatic compounds. If you try to join end to end or try to get it bridged or try to get it fused. Now, here two meaning comes. What? One is your fusion and one is your bridging. Okay. These two techniques will help an aliphatic chain either to be covered in a cyclic form. Right? You got? So, now here another system came into existence, that is your cyclic system. If I want to introduce any other atom other than the homo atoms, okay, that is your benzene ring is a classic example, your cyclic ether is a classic example of your homocyclic structures. If I introduce other than carbon and hydrogen, other atoms, those will be called as your heteroatoms. The classic example for your heteroatoms is oxygen, nitrogen and sulfur. Fine. This is the example for your heterocyclic systems. Now, I will go back to the first thing. What I said, that was what is the need for your classification and nomenclature. Because after your first introduction to your pharmaceutical chemistry, to your introduction to your heterocyclic systems, we are going to profoundly study all the different classifications related to your organic chemistry. That will be your antiseptics and disinfectants, could be antihelmintics, to be a neoplastic, cancer agents, to your chemotherapeutic agents, diagnostic agents, then central nervous system agents, okay, ANS, CNS, peripheral nervous system and cardiovascular. Prior to that, one should know what is the mode of acting of an chemical or a drug. So that was the need for the classification, that we should understand what is the classification based on. Now there will be a variety of classification. We should know what is the basis of classification for your chemical nature. Means depending upon the chemical structure, your drugs will be classified. Now over here means quinine will be under one family. Sulfonamides will be under one family. Amines will be under one family. And so on. The urea, sulfonils, then ureas, These are the different kind of drugs which will be held under one category, that is under one chemical structure. So the first classification is here based upon your chemical structure. Now, why this will help you to understand the succeeding chapters which are going to come after your first chapter. Means take examples. If we are going to start with your antimalarials, the first classification will be based drugs classification of your antimalarials based upon your chemical structure. Means over here all the quinine families will be the drug of choice of classification, right? So this is the first thing, that classification comes under the category of your chemical structures, right? Then let's study the second one, that is drugs based upon your therapeutic actions. How the drug shows a particular action into the body, that is your therapeutic action. Okay, now over here there are drugs which are being classified upon based upon your therapeutic actions. Means when you take a drug, say XYZ, give you a classic example of your cetirizine. These days when you have your cold, a common cold and cough, what you do normally, or you go for a good anti-cold tablet, you go for a good cetirizine tablet, a simple example I'm giving you, or go for a simple headache, you go for a choice of your Combiflame. So what is the therapeutic action being shown? How the drug is being broken down into your body, how far the pharmacological action takes place, what amount of drug is being biologically active in the body, and how long or for how prolonged or how far the drug shows its potency or how far the drug shows its action. It is being thus decided upon what type of dose or what amount of dose one goes to. So that the whole study will be under your therapeutic action. Means there will be classification of drugs based upon your therapeutic activity. Then over here again you have based upon your therapeutic action, you will be having drugs based upon your CNS, PNS, cardiovascular system. Okay, means drugs which are acting on your central nervous system, drugs which are acting on your peripheral nervous system, on your autonomic nervous system, then your cardiovascular system, okay, and so on. So that will be your chemotherapeutic agents as well, that will be a metabolic disease as well, vitamins, endocrine glands, your steroids. So there will be a variety of drugs which will be classified under the therapeutic actions, right? Now you get why are we studying the different classification, that is based upon your chemical structures, then based upon your therapeutic action. In that you are having n number of varieties, n number of different categories, or the classification again goes into the deeper classification, that is your central nervous system, ANS, okay, and ANS, PNS, and your cardiovascular system. Now when we say CNS agents, so what clicks our mind? All those precise drugs which will be used for your which will be acting directly onto your central nervous system. Here we will have a lot many of drugs dealing, that will be say for classic example antidepressants, then your antipsychotics, and then your anti-anxiolytics, then your psychomimetics, anticonvulsants, then treatment for your epilepsy, and so on. You are having a variety of drugs or varied classification based upon your central nervous system. A very important classification students come is your pharmacodynamic classifications or pharmacodynamic agents. Over here, that will be all your vasodilators. Okay, those drugs which will be acting through your normal dynamic processes, which will include into your antiarrhythmic, antihypertensive, anti-anginal drugs. So again, that will be again categorized as per their classification. Next comes is your chemotherapeutic agents, as I said, then endocrine, hormones, steroids, vitamins, and your hormones. So this will be the basis of your classification. Once you understand the classification and nomenclature, again that is your IUPAC nomenclature, that is your systemic and your non-systemic classification. So based upon these two classification, you're going to study the chemical structure of your drug, and that is your nomenclature. Okay, now today let's start. This is only about the peripheral idea one should know prior starting to the direct studies of your heterocyclic systems. Now, in heterocyclic systems, in organic chemistry, precisely we are talking about your organic chemistry. In your organic chemistry, it is the structure, it is a study of structures, the study of chemistry of your organic compounds on the basis of your carbon skeleton. Now, when we say carbon skeleton means your aliphatic chain, or could be when you join end-to-end carbon bodies, they become a structural moiety, that is your cyclic system. Okay, so one should understand what is your carbon length, what is your carbon skeleton, and based upon that you will say the organic compounds are classified as your open chain and your closed chain. Open chain and closed chain, right? So open chain compounds will be what? Once you know what is your carbon skeleton. Carbon skeleton means what? What are the number of carbon compounds present over here? Based upon that, you will categorize is that as your open chain and your closed chain. When we say open chain, what strikes our mind? That it will be again an unbranched chain and an branched chain. The very good example is your N-butane. When we say N-butane, so that means how many? C4H10. C4H10, that is your N-butane. Example. Means you know, once you know what is the structure of your butane and whether it is being placed as an branched or unbranched, on basis of that, one will get a thorough understanding of knowing whether the structure is your unbranched or your branched chain. When I say such N-butane, then it is your unbranched chain. Okay. Unbranched means what, students? Unbranched means when there is a single carbon aliphatic chain and there is no further branching. Means either 1, 2, 3, 4 carbon. Right from your carbon number 1 to your carbon number 4, there is no such branching. Branching means what? If I start at your carbon number 2, I again add one single carbon atom, and again the branching goes on, or it continues in a similar fashion. So that is called as your branching. So this is the example of your N-butane, which is your open chain, again under the category of your non-branched. That is your unbranched. So you understood what? That we'll just have a revision. Under the classification of your organic compounds, your compounds will be structurally classified as your open chain and your closed chain. In your open chain, you will be having unbranched and your branched one. When we say branched, that is your 2-methylpropane. If I give you example, second will be your branched 2-methylpropane. Now, when we say propane, how many carbon comes into your mind? N-methylpropane. Okay, so that is your methane, ethane, and your propane. So carbon 3 and 2-methyl 1, 2, and 3. Let's give numbering. Propane means 3 carbons. Let's go for the numbering. That is your 1, 2, and 3. And let's start with the balancing of your carbons and your hydrogens. Now, when we say 2-methyl, in the propane chain, your second carbon will be having a branching, that is your methyl. So, this will be categorized under the heading of your open chain into your branched chain compounds. You understood what is the difference between your unbranched and your branched one? in branching, they will be either for your second position, could be for your third position, depending upon what the given structure is. Okay. Now let's see, have a look towards your closed chain or your cyclic compounds. The second classification is your closed chain or your cyclic. When we say closed chain, either there will be your end to end, you're going to get it joined all together, and that will be the classic example for creating a cyclic structure. A very good example is your benzene. You have studied benzene right from your 11th and 12th standard, right? The very good, the next classification for your cyclic structures goes as your homocyclic and your heterocyclic. So this will be again your homocyclic and your heterocyclic compounds. Now homocyclic means what? Our chapter's name is your heterocyclic systems, and prior to that one should understand the whole lot of components that is covered into your structural chemistry. So when we say cyclic, so that will be again categorized as your homocyclic and your heterocyclic. Classic example of your homocyclic is your benzene or your cyclohexane. If I say example is your benzene. So benzene, you know, they are having only 2 carbon, they are having all such carbon and hydrogen moieties or atoms. Those are again in the similar fashion. Other than your carbon and hydrogen, no other foreign member or no other heteroatoms. Heteros means what? Other than the normal family, whenever who includes, that will be your heteroatoms. So when we say benzene, if you want to add another carbon, if you want to replace or add other than your carbon, that will be again, you can add benzene, you can turn benzene into a heterocyclic if you add your nitrogen, oxygen and your sulfur. Heteros, you have to remember, that is your SON, sulfur, nitrogen and your oxygen. Even the preferential rule we are going to study later on. So in heterosystems, we will see homocyclic is the classic example for your benzene, and for your heterocycle, when you are other than your carbon and hydrogen, if you introduce another atom, that is your sulfur, nitrogen and oxygen, will be called as your heteroatoms, right? So the classic example for your heterocyclic is what? Your furan, could your pyridine. Now pyridine, students, you all know, pyridine is nothing but your 1 nitrogen atom. Means, if I say, this is your benzene, right? Having only, if I don't put CC, you can understand, this is CH, C6H6. This is your C6H6. You understand? C6H5, 1, 2, 3, 4, 5, 6. Okay. You all understand all these things. But if I put another moiety over here, or if I put furan, if I introduce nitrogen, if I introduce sulfur, if I introduce your oxygen, what will be it called as? It will be called as your heterocyclic systems. Heteros means other than your carbon and hydrogen, that is sulfur, nitrogen and oxygen. And cyclic means what? They are being placed structurally in a form of a cycle. So that will be called as your heterocyclic systems. Your example is your furan, pyridine. When I say pyridine, if I replace your carbon moiety with nitrogen, that will be called as your pyridine. Okay. And if I introduce more than 1 nitrogen atom, that will be your pyrimidine. Means if I introduce 2 nitrogen over here, that will be again turned into your pyrimidine. Means I am going to introduce 2 heteroatoms into your normal homocyclic benzene system, and hence the total structure, the total chemistry of that particular structure changes, chemical compound changes, and it is being classified under the category of your heterocyclic systems. Okay, heterocyclic systems can be either aliphatic or either could be an aromatic. When we say aliphatic, then you can understand they are placed into one single carbon chain, that will be called as your aliphatic chain. And if you want to place it in an aromatic chain, that will be called as a aromatic compounds. The very good example is nothing of, or you could say a nitrohydrofurans, you could say your furan structures. That will be again cycloethanes. Okay, so this is nothing but your examples for your heterocyclic systems. So this is all regarding your just introduction to your heterocyclic systems.